Hello, this is for page 133 for your notes. All right, so think about what this is. We're multiplying the two exact same radicals together, which theoretically comes out to square root of 4. But we know square root of 4 is 2. Well, look at this. Notice this 2 is the same as that. So this is 64. The square root of 64 is 8. Notice how these are the same. So what do you think this 97 is going to be? I mean, this would give us a big number. But the square root of that big number actually would just come out to 97. So what about if I do x times x? Well, that's x squared, but wait a minute. If we look back here and here, when we have the same two radicals multiplied to each other, your answer became without the radical. So this actually just comes out to x. What about this one here? This comes out to, what do we have under the radical? X squared. What do we think this last one might be? Yeah, it's x to the third, because basically that would have become x to the sixth, which actually, when you take the square root with an exponent, you take half the exponent. Okay? So this one, I have an exponent of 1. If I take half of 1, I get the same thing. Take the square root of this, I'm going to take half of the exponent, so my answer is just x. I'm going to take half of just the exponent, so it's x squared. I'm going to take half the exponent, so it's x to the third. No longer have a square root sign. This one has a square root sign because if I take half of 1, I get half. Square root of this one, take half of the exponent, so I just got x to the fourth. I no longer have the square root sign, or the radical sign. That's called a radical sign. Or you might know it as a square root sign right now. All right, let's take a look at this. Well, what's the square root of 4? Yeah, it's 2. And remember, if I take the square root, I'm going to take half the exponent. Half of 2 is 1, so I get x. There's no longer a radical sign. Now we get a little deeper. I can't take half of 3. I mean, I get 1.5. That's not going to help us. But could I change this to x squared times x to the first? Because remember, like bases, when you're multiplying the bases, you would add the exponents. So 2 plus 1 is 3. So if I do that, what's the square root of this? Yeah, it comes out to x. And then I'm left with this stays underneath the radical sign or under the square root sign. So x square root x. Let's see if we can perform the same thing here. I want to make one of them be an even number. The other one is just going to be x to the first, because remember, when like bases, when multiplying, I add the exponent, so 4 plus 1 is 5. So the square root of x to the fourth is going to give me x to the squared. And then this stays behind. There's my answer. All right, so a little trickier. We have a couple things to do. 20 we have to break down. So 20 falls about in here. So think about it. 4 times 5, 4 is the biggest perfect square. So I can go 4 times 5, and then I'm going to break this down. And I want an even number, and then it's the first. Okay, the square root of 4 is 2. That comes outside the radical sign. Square root of x to the sixth, well, take half of the exponent, so that's x to the third. Then I'm left with 5x to the first. I don't have to put the 1 there. I could if I wanted to. There's my answer. Think about this one. Oh, that's a perfect square, isn't it? Is this a perfect square? Well, it's an even number, so yes. So then I just need to say, okay, I have a 6 and an x that come out. But then the y to the third, could I break y to the third down to this? Are these the same? Yes, they are. So square root of y squared, take half the exponent is y, square root y. So 6xy square root y is our answer. Okay, this is not a perfect square, but what's a really big perfect square that works with 200? Yeah, 100 times 2. 100 is the biggest perfect square. Okay, you could have chosen 4 and 50, but 4 is not the biggest perfect square. A squared is perfect square. B to the third I'm going to change to B to the second times B to the first. And C to the fourth is a perfect square because it's an even number. So the square root of 100 is 10. The square root of A squared is A. The square root of B squared is B. The square root of C to the fourth, take half the exponent, so it becomes C to the second. What do I have left behind? Well, I have a 2, and I have a B to the first, or just B. So 10abc squared square root 2b. Okay, so let's put these together. So that's going to give me 180. Now remember, here and here, we add the exponents because we're multiplying the bases. So that's a perfect square. That's great. This one, I could make it y to the third, but I would just wind up turning it back into this, where we'd have the perfect square being y squared. Now I want to break up 180. So let's list our perfect squares. Okay, so let's take a look at this. What can we break 180 down? Oh, you know what? Would let's see. Where would we want to break this down? 180 would be the same thing as 2 times 90. 90 is the same thing as 2 times 45. 45 is the same thing as 9 times 5. So 4, 9. So 36 times 5 gets me 180. Okay. X to the 8th is perfect square. Y squared is perfect square. Y. So square root of 36 is 6. Square root of x to the 8th, take half of it. It's x to the 4th. Square root of y squared is just y, or y to the first. What do I still have left behind? I have a 5 and a y. There's my answer, 6x to the 4th y, square root 5y. And that's all you have for the homework. Make sure you ask me in class, and I'm happy to go over anything to clarify with you. But I would like you to work on page 135, 136, and I think you can do 1 through 17, and I think you could do all of them. Okay, have a great day. Let me know if you need any help. Bye-bye.